Okay, it says the distance that you, d that you bike varies directly with the amount of time t that you bike. So essentially what this is saying is that you're biking at a um, steady rate. You're not speeding up and slowing down. So suppose you bike 13.2 miles in 1.25 hours. What is an equation that relates d and t? And then what's the graph of it? Well, what we really want to do is identify what's the independent variable and what's the dependent variable. So time is typically the independent variable. And so x is often used as the independent variable, but in this case, we're saying it's going to be time, t. Okay, so these two, we're going to use them interchangeably, or we're really going to use t instead of x. Okay, and likewise, y is what results. You say, okay, after a certain amount of time, how much, what distance have you gone? So the distance d is going to be essentially the dependent variable, or the y, the vertical axis on in this case. So the reason that I'm saying that is because we've got this direct variation equation that is y equals kx, okay? And what we're going to then have to do is, if we wanted to find out, how do we find that k value? Well, we would need to divide both sides by x, and you would find that k is equal to, what's there? Y over x. So in this particular case, if we want to use the variables that they're giving us, then instead of y, we're going to be using d, and instead of x, we're going to be using t, as it says up top. So really, we can find the k value by dividing d divided by t. And once we do that, then we can set that up as a direct variation equation, like y equals kx, or using the variables that they gave us, d, the distance, equals k, the rate at which we're riding, times time. Okay? So we'll eventually get to this. But right now, let's first just calculate, what is that k value? So as we said, t is the independent variable, and the distance d is the dependent variable. And we're always using, since we're starting with the y, let me use my pen, sorry. Since we're starting with y equals kx, or if we are writing it in the variables we gave us, then the distance is equal to kt, then in that case we divide both sides by t. As I just said, to find k, we're doing d divided by t. So k equals d divided by t, and substituting in, what do they give us for d? They give us a distance of 13.2 miles and a t time of 1.25. Okay. I'm going to write the math calculation over here, the division problem that divides 13.2 divided by 1.25, and I'll do it in red. I'm going to write it over the graph, and then I'll get rid of it. But we've got 13.2 divided by 1.25, and there's a rule that says we can turn this into a whole number, 125, by moving the decimal over 2 places. And if we move the decimal over 2 places here, we will get the exact same solution, but we of course have to fill in a 0 there. We're going to get the problem 125, 1,320 divided by 125. So I'm going to do this division here. 125 goes into 132 one time, minus 125, and we're left with a 7, bring down the 0. There's a decimal there, we're going to bring it straight up. How many times does 125 go into 70? It does not, so 0 times. I'm going to annex, or add on, another 0 at the end, bring it down. How many times does 125 go into 700? Well, it can't go in 7 times, because it's bigger than 100. It can't even go in 6 times, because if we multiply the 100 by 6, we get 600, and if we multiply this by 6, it's greater than the other 100 that's left. to get from 600 to 700. So I'm going to go over here and I'm going to say, what about 5? 125 times 5. 12, carry the 1, 625. 625, that was 5 times. And when we subtract that, we get 75. Oops. 75. And then we annex another 0, bring it down. And 750 is exactly 125 times 6. So we get 750 and 0. And we've got as an answer 10.56 as our k value. So I'm going to write that over on the side. K is equal to 10.56. And I'm going to erase all this and then we'll go do the rest of this. Actually, first I'm going to write the equation because I know that it should be distance equals the k value, in this case 10.56, times time. And an interesting question here is, what does this number represent? Well, we can think about it by plugging in 1 for time, meaning 1 hour. If we went 1 hour, 1 times 10.56 is 10.56 as a distance in miles. So that must mean that we're going 10.56 miles per hour on our bicycle. So that's our equation. Let me get rid of the rest. Okay. So that's first part of our answer, because they asked what is the equation. That is the equation in terms of the variables they gave us. And then they want us to graph it. And there's a couple of things that we could do. I'm going to mark out our graph here. Just give me a second to do that. And we only need 2 points in order to make a linear graph. We need to just plot 2 of the points. One point we always know with these direct variation equations is 0, 0. So I can plot a point there. Another point that I can plot would be, and just to be clear, this is the time, t, and this is the distance that results from riding for that amount of time, d. So we're clear on which variables we're using. So if that's true, then I could use the point 1.25, comma, 13.2, which is the information they gave us, that you rode for 1.25 hours and went 13.2 miles as a result. So I'm going to plot that. And how do I do it? I go over to 1.25 on the x-axis. I chose 4 boxes makes 1, so that means that each one is 0.25. So here's 0.25, 0.50, 0.75, 1, 1.25. So I'm going to be on this vertical line somewhere. Okay? And in fact, exactly where? I'm going to go up here to, I'm going by 2s on this scale. So 2, 4, 6, 8, 10, 12. And since this is 12 and this is 14, right in the middle is 13, so a little bit above that. And so that's where I'm going to plot my point. 1.25, 13.2.